There we go. We are now recording. So welcome back, everybody. Hope you enjoyed your afternoon tea, or it'd be breakfast for some of you, or a very late supper for some of you today. So it gives me great pleasure to welcome three of our next guests. So Costin, Chad, and Nigel, who are going to be talking to us about mainframe passwords. And I think that the way that this session is going to flow, there's like a 20-minute presentation, and then it's going to be a panel discussion with Q&A. So this is going to be very much an interactive session. And remember what I said earlier on today, of course, we are a working group. So don't be afraid to pitch in on the chat. Your lines, you can unmute them if you want, and we'll also be doing a little poll as well. So do keep an eye out for that. But without further ado, gentlemen, over to you.
Okay, thanks, Jamie. So yeah, I'll try to make this short, as we only want to spend 20 minutes on the slides and then move on to a discussion. So who we are, probably know at least a couple of us. This is Chad. He's working for BMC, XRSM. He's been doing a lot of VAPT projects for mainframe installations and for very large companies, probably for some of you too. It's Nigel. You all know Nigel, you should know him. He's been the authority on mainframe passwords for many years, and he's written those tools that we've all been using. And it's myself, Costin. I'm security consultant. I'm also doing VAPT projects for mainframes. I've been doing this for the past 20 years. And I'm also the author of ePass, which is a tool set for password analytics that I'm going to use later on for some benchmarking against KDFAS. So why we got together, why the three of us, what we have in common probably is that we invest a lot of time to understand how mainframe security works under the hood. Not necessarily just we've been told, but we want to see more. And the particular topic of KDFAS, password hashing, that's what we're going to look in today. That's something we've been told by the vendor that is good. We are told that it's better than DES, but so far we've seen no real proof of that. And this is why we are going to get this proof ourselves today. And okay, as usual, any password-related presentation, we start with the history. We start from 1976, years I was born. IBM introduced masked passwords. This is obfuscation, and it's also reversible passwords. It may seem naive by today's standards, but at that time, in 76, even having a password was bleeding edge kind of security. So most systems didn't even have a password. So this was good, and masking, obfuscating it in a way was even better. So it was, I would say, a good initiative. 1984, we got DES, password encryption. This is where we encrypt the username of the password, use as a key. This is appropriate. It's a proper algorithm for the time. It's using DES, which was standardized in 77. So it was the state-of-the-art technology at the time. And on top of this, by default, this algorithm uses salted passwords. That means that if we have multiple users sharing the same password, they will not have the same password hash. This makes it much more difficult to crack these hashes. Just to put this a bit into perspective, or how visionary IBM was at the time, Microsoft does not employ salted hashes even today for their operating systems. 1994, DES became the default password option, which is a good thing. 2005, we were given mixed case passwords. This is again a security improvement because we have much larger key space available, so password cracking gets even more difficult if applications support mixed case passwords. Then in 2006, password phrases became available. Now, password phrases, as was discussed a little bit today as well, are designed to be used in parallel with passwords for those applications which support entering longer identification keywords. So they will work in parallel with passwords, and they can be very long because they are phrases, and therefore we have a significantly increased key space. So apparently it's a very good security improvement. However, the implementation of the password phrase backend storage was at the time a textbook example of how not to do password hashes. So first of all, the encryption algorithm is similar to the way the passwords are stored, meaning that we still encrypt the username with something. It's done in consecutive 8-character blocks, and it's using a form which is not standard of block encryption, which is not standard. It's invented by IBM, and is not particularly good in this case because we can crack 8 characters at a time. That means that the increase in complexity is not growing as expected exponentially, but just linearly compared to passwords. On top of that, for unknown reasons, IBM has decided to truncate the resulting hash to the length of the actual password. This yields collisions. That means that if we don't have a password phrase which is an exact multiple of 8, we will see collisions. An example below, IBM user with the password phrase a good password 2001, or with the password phrase a good password 2002 will yield exactly the same hash. And of course, they both will work. Moving on to our main subject, 2014, KDF-AES became available as an IPA, undisclosed by IBM, so specifics are not disclosed. It gives us a lot of new things. It gives us good encryption, and it also gives us special characters possibilities for passwords, and it solves the problem of the password phrase disencryption created in 2006. 1 year later, the KDF algorithm was, let's call it, discovered, independently discovered, so the specifics became known by at least 2 independent researchers. That's Chad and myself, probably others as well, but they just didn't tell us. And we've had in 2017 the first KDF-AES implementation in Hashcat by using OpenCL acceleration, so GPU acceleration, which is the fast implementation. Actually, Chad had it earlier for John the Ripper. I will see the link immediately. It's a bit about the password history in RACAF. Now, because we've been talking about KDF-AES, let's see how the algorithm is actually implemented. We have a first step where we calculate the input for the key derivation function. For passwords, it is the old DES password. That means that we still encrypt the username with the password. That also means that we can have one-way migration of the old DES passwords. We just skip step 1. For password phrases, this is done differently, meaning that the input phrase will be sent through an SHA-256 function and concatenated with the length of the phrase. That means that no migration will be possible for these phrases, which is good, because you've seen they were not stored very well anyway. Step 2 is the actual key derivation. That's the thing that makes the algorithm strong. So this is the thing that takes a very long time to perform. It is based on a custom IBM version of PBKDF2 with SHA-256, and in its default configuration, what all of you will be using now, if you are using KDF-AES, it will do 45,008 rounds. So we can see the function below. A random salt is chosen. We have the input from the previous step, and we perform the PBKDF2 derivation. In step 3, the username is encrypted by using AES-256 with the key derived in step 2. In the end, we have a hash of 32 bytes, which is a concatenation of the result of the encryption plus the random salt that was used to derive the key. Unexpected bonus, or expected, this is quantum safe because both SHA-256 and AES-256 are believed to be safe. There are 2 factors included with the algorithm customization. One is the memory and the other one is the repetition factors. This can be customized and they are stored within the hash. This allows us to have an algorithm which is future-proof. That means we can make it slower in case the potential attacker's hardware gets faster. This is not in use for now, but if we max out these parameters, the computation time is increased by about 4,500 times, which is huge. You don't want to use this today. At the bottom of the slide, you have a link to Chad's code, C code, if you want to go into the very specifics. It's very clear, C code, and it's a plugin for John the Ripper. Okay, so we saw how the algorithm actually works. Let's see the tools that can be used to try, attempt, maybe succeed in cracking KDFAS protected passwords. We can have, and typically we have clusters. This is just putting together multiple GPU accelerated servers. This is very scalable, indefinitely scalable. It only depends on the size of your pocket. It's not very energy efficient, but you don't have to build it all at once. You can increase capacity later. You can have a very large single unit computer, single CPU computer with, in our testing lab, 10 GPU units. We are using NVIDIA 3090, which is the latest generation. It's very efficient, very energy efficient, and is probably the most powerful unit you can build today on the planet, unless you count the spy shops. And the very cost-effective version, because we live in the cloud era, you can go out and rent yourself an Amazon GPU powered with 8 Tesla units for 20 euro an hour. This is very useful for single hacking jobs. Now, the benchmarks you will see immediately are based on a single unit from a GPU cluster, as the one that we have on the screen now. So we don't want it to be very fast. We just want to have consistent numbers that we can compare. As I said before, I'm going to use our EPAS tool to show how the numbers actually compare. We will begin with a brute force attack against DES for reference, so we know where we start from. That means trying all the possible character combinations up to a given length, 8 characters in our case. We use the standard character set for RecF passwords, the uppercase version, only one user. As we can see in the highlighted window, this yields about 8 billion hashes per second, which is what we expect for this nowadays. And that means that we have a guaranteed password recovery within 13 minutes on this particular GPU accelerated unit, which is of course a short time, and this is why we don't want to be using DES. Now let's compare this to KDFAS. We have the same unit, the same accelerated unit, the same password, so everything is identical. It's just that our password has been migrated to KDFAS. We have a guaranteed recovery time of 858 days. That's an improvement compared to the previous situation. The speed we can achieve by using one GPU in real life is between 70 and 80,000 hashes per second. We are using GPU acceleration because, as you can see at the bottom of the screen, if we use a normal PC, a very powerful PC with all possible optimizations, we will not get much more than 1,000 hashes per second. So this is far too slow to do any kind of benchmarking or to do any kind of hacking or cracking of these passwords. The next test case is based on word list. Word list is another type of attack, which is actually the most common attack, where all the words in a prepared word list will be tested against your hashes. We are taking here an example of 35 million words. These are language words from the English dictionary, combined with a number of leaked passwords and passwords that are taken out of the company, potential passwords taken from the company branding information. We see here that for this, we have about 500 million hashes per second. This is normal because we have a lot of I/O. We have to feed the GPU with all these password candidates. Nevertheless, the DES key space is completed for 100 users within 5 seconds. If we compare this to KDFAS, exactly the same test case, it takes us 6 hours. That's much longer, but it's doable. Now, it's not like we have to wait 3 years. It's an attack that I can imagine taking place. So let's look at the numbers compared, what we learned from the benchmarking. If we compare the typical high power appliances that we can build today, we have this very large GPU-based worker with 10 units and so on. This will yield about 800,000 hashes per second for KDF AES. This is still very slow compared with DES that we can see below, or NTLM, everyone's favorite. Or we can use an Amazon EC2 unit. As I said, it's about 20 euro per hour. It will give us a lower performance, but it will be cheaper. So if we compare this, the apparent improvement with numbers compared between KDF AES is that it is about 85,000 times harder to crack KDF AES than DES via brute force attacks. And for reference, it's about 1.5 million times harder than cracking Microsoft NTLM. Just to put this a bit into perspective, if we compare 2010 and 2020, because we want to know what is the improvement reported to the time when this technology was being massively used. If we look at what 3,000 euro could buy us in 2010 as compared to what 3,000 euro can buy us in 2020, in 2010, we could have achieved somewhere between 6 million hashes per second up to 200 million hashes per second for DES, the technology of the time. And for KDF AES, for the same amount of money, so 3,000 euro will buy us about 1 week of Amazon cloud service. It's between 80,000 and 570,000 hashes. That means that our adjusted improvement is between 11 and 2,500 times harder to crack a RECF password in 2020 if someone uses KDF AES compared to 2010. Now, what kind of attacks are still possible against KDF AES hashes? Are we now completely safe or not? One thing is clear, brute force attacks are no longer going to work. It will take like forever. Nobody's going to try this any longer. We do have hardware and cloud resources that can provide us somewhere between 80 and 800,000 hashes per second. Now, that means that hash cracking is still possible, but we need to trim down our key space. We need to have less password candidates than we had before. Otherwise, it will again take forever. Our attackers would do this anyway. So let's see how a real attack will actually take place. One, we'll try to minimize the number of users. So we are going to target service accounts, privileged accounts, developer, TSOs, things that can be used in the attack. We don't want to crack everyone's password because there may be hundreds of thousands of accounts, people long dead included. And we need to trim down also the word list that we are going to try against those passwords. So we are not going to try everything because it will take far too long, but we are going to customize our attack. We are going to use leaked passwords, company branding information, or even better, what do we do when we run a RECF pen test? We're going to leverage information from the environment, like taking a weak system first, like Active Directory, crack those passwords, count on the fact that people are going to use identical or similar passwords on the mainframe, and use that thing as an input. Let's see a quick example. This is a password audio of an Active Directory with 10,000 users, employing exactly the same hardware that you've seen before, 12-character passwords and so on. This gives us, a cracking job will take about 2 hours if we want to recover around 80% of the passwords. So in about 2 hours, we have obtained 80% of the passwords in Active Directory, which is quite fast. We can see in the graph here that we have a perfectly normal password strength. This is language adjusted entropy distribution as well as the length. Now, this is very typical because our test case here, the system I built specially for this to work, uses real passwords, not imaginary ones, passwords taken from real users. Now we are going to use these passwords. We can see we have 8,600 passwords that we recover from AD against our KDF AES RECF database with 100 users. If we look at the speed of the attack, the speed is the expected one, so we have 62,000 hashes per second. It takes us 17 seconds to go through the entire key space. With all the overhead, I would say we have a complete passing of the key space, of complete testing of a key space for this database in 2 minutes. So because this was a system I prepared especially for this, we've been able to recover all the KDF-AES passwords for our selection of 100 users within 2 minutes. In real life, there will be less, of course, because passwords will not always be the same, but one can often count on single sign-on and identity management solutions to keep your password synchronized. So if you're using that, then it will be a 100% hit. Now, a few conclusions before we move on to the discussion. We understand that attacks against password hashes on RACF, KDF password hashes on RACF offline attacks are still possible, but they're much harder and yield less correct passwords. And now we have an objective proof for that, so it's not just like maybe. However, as long as weaker systems exist in the environment, the mainframe will also be affected by that. So in the days when everyone uses a Windows workstation to connect the mainframe, well, mainframe security efforts no longer make sense if they're isolated from the rest. However, password cracking is usually not the way mainframes are hacked, but it is, in most of the cases, instrumental. So ideally, make sure that strong passwords are used, or password phrases, of course, it's far stronger, and try to make sure they are not the same or they're not similar to other weaker systems, and or God forbid, LinkedIn or someone else. Password spraying attacks can be used to hack mainframes. So make sure you detect leaked passwords and make sure you have enough logging and alerting in case massive amounts of passwords are thrown against your users. And something to keep in mind is if you are using RSF, make sure that all the components will use KDF-AES, all the RACF instances, because the password is transmitted in clear text between the different instances, and it's hashed by each RACF instance with its own algorithm. So if it's DES, it will be DES. If it's masking, it will be masking. And that's it for the intro. 20 minutes, yep. So what we want to do now is to answer some questions, or to answer some questions we're asking ourselves if there are no questions for us. But we have about 40 minutes at our disposal. You can also unmute or, okay, we have
some questions coming in. Very good intro, by the way. I'm shocked by the results. Yeah.
I do this for a living, it's okay.
Yes.
I mean, the one thing I would mention on that, though, is I'm not personally convinced that passphrases are inherently more secure than passwords, because you still get the problem of people tend to think up the same things. And out there on the sort of word lists, it's early days yet, but there are progressively more and more word lists appearing that are passphrase word lists, and not least because a lot of them come from words from songs and poems and well-known sources. So that it suffers from this exactly the same problem. If it's not randomly generated, people will tend to be tempted towards the more familiar.
To add on this, Nigel, I mean, we've been asked to solve this dilemma for law enforcement where they needed to crack password phrases. If we look at a password, we have typically a large number of potential characters, like, I don't know, 30 different characters that we can use, and the small number of combinations we can make because it's a short password. But if we look at password phrases, then we have a huge number of, let's say, tokens, which are this time not characters, but they are words from, let's say, from the English dictionary. And it's even larger because you can have different capitalization. But you have very few combinations. You know, you can have 3 or 4 words. So this is like, if we compare it cryptographically, it's like a very, very short password with only 3 or 4 characters, but from a language with many characters, different characters. So it seems more complicated, but nobody's going to try to crack password phrases with brute force. Nobody's crazy enough to attempt that. They are going to build combinations of words from dictionaries and change the capitalization. It will be more complicated. It will take longer than a password, but not much longer.
But again, you're assuming that the user is going to be good at picking a password. But users, users are typically lazy, and if they have a tune or something that they know, that they will tend to pick that. So I mean,
I think it's incumbent on us to make it. I mean, we say users are lazy. I'm not sure that's fair. I think it's incumbent on us to make authentication mechanisms that are easy for users to use, that are still secure. I mean, at the end of the day, if we're still asking, people are terrible at entropy, to your point, right, Nigel? And and if we're still asking them to come up with something, they're going to take the easiest route. And I think that, you know, passphrases are definitely better than an 8-character pass. You know, it is very difficult to pick a strong 8-character password and remember it. Whereas most of the places I end up in, you know, cracking their racket databases, they end up with, you know, some are 01, 02, 03, 04, or to Costin's point, you know, we'll dump all the passwords on the Windows network and then just truncate them down and try the first 8 characters of all of those passwords on the mainframe, and, you know, we hit 80% of them because people they're lazy, or we've made it so easy to do self-service password resets across the enterprise, one-stop password reset, right? So everybody wants their password synced everywhere so they don't have to remember 15 passwords. I mean, this is a case for a password manager at the end of the day, right? Where, you know, you make it mandatory for people to use something like that, where they have a one strong password to manage them all, and then a series of, you know, complicated and randomized passwords underneath that they don't have to remember. And I think that at least in the organizations I've been in that enforce that, they've basically taken password cracking off the table as something that an attacker can use.
Just picking up on the one thing you said there, Chad, this whole business of having passwords with a sequencing number on the end, I don't know if Jamie would fancy doing another quick poll. How many people are still mandating the forced periodic changing of passwords? Because that's basically what drives that one.
So Bruce Wells, and I'm sure everybody knows of IBM Racket fame, asked in the chat, I'm curious whether you think people are getting overconfident by suggesting longer expiration intervals or eliminating them outright. What password interval do you recommend? I'm like anything, it depends, and I'm interested what you folks have to say as well. But I would say that Nigel's exactly right. If you force people into an 8-character password, which is difficult, what they generally end up doing is coming up with a 6-character word and a couple of letters, or a 6-character word and a letter and a symbol, so, right? So they have, you know, spring $1 or something like that. Or they end up with, you know, everywhere we go, my friend Phil and I make this joke, everywhere we go, if we end up with a list of users and we can try one password across all the list of users, would do something like Feb at 2021, right? Or 2021 at Feb, or something like that. And you'll get a hit if you've got tens of thousands of users, because people are rubbish at this, right? They're terrible at this. And so to answer Bruce's question, I mean, at least if you can give people longer passwords and passphrases, meaning you can give them 12 or 16 characters in passphrases, then I would say annually or twice a year. If you're still forcing people into 8 and you're doing it every 30 days, eventually the weariness factor will take over, and you're going to end up with the, you know, spring 01, spring 02, spring 03 sort of thing.
To add on this, Chad, as we are cracking passwords for a living, we're doing password assessment for very large enterprises. We've seen ones using password phrases and using only passwords. Of course, most of them will be still using traditional passwords, but some are switching, for at least for some applications, to password phrases. And we've seen the strengths of that. So that I think there are two factors to consider. One is definitely you should move away from that 8-character password. End of the story. It's not good. It's not going to be good. All the measures you are putting in place is still going to be bad because people are people. So switch to password phrases, and then make sure that you are not syncing them to anything else, because they might be good, but they will be found somehow. Either use a different password phrase on your RACF, or if it's not, it has to be possible. If people cannot remember many passwords, as Chad said, use password managers. That's the way to go. Of course, there are other alternatives. You can use certificates, MFA, and so on. But let's not trick ourselves. 90% of the user will be still using a form of password. So let it be a password phrase and let it be unique. And in this case, the recovery rate we've seen in as I said, in large enterprise, it's talking about hundreds of thousands of users, went down from 80% to 2 or 3% just badly chosen password phrases. So I think the improvement is huge.
Can I just throw something into the mix here, because there's an organisation I heard about that they had still with 8-character passwords, and they had a password change interval of something, I want to say 30 or 35 days. But the CIO said, look, we want to cut down on the traffic going to the service desk, because there were like long delays in getting your call answered, because there were people doing password resets, blah, blah, blah. So the way that they try to sort of solve the call traffic on password resets was to increase the password interval. And I think it went up to something like 90, maybe 100 days. But what's stopping them going to passphrase? So there was a concern there that, like, okay, well, you've shifted now the goalpost, but are the users doing any better job of making a stronger password? Probably not. But the inhibitor there for them is like going to password phrases. I think there's some old applications that have got to be updated or something. I can't remember the history, but they can't actually at this moment in time move to password phrases. And the other challenge that they've got is that they're synchronizing passwords between AD and other authentication systems, including RACF. So it's a kind of more of a convenience thing, I would say. Reduce the statistics of long wait times. So you've got the other side of the spectrum.
We've been in organizations, Jamie, where I've done where they do that synchronization you mentioned, and we've done sort of hybrid penetration testing or red team exercises with another team that's focused on, say, Active Directory and the wider network, and we're focused on mainframe. And more than once, we've used the mainframe to breach the rest of the network, right? Mm-hmm. So we've gone onto the mainframe, grabbed the credentials off the mainframe, and then used them in reverse to get back access into the Windows network, because the mainframe was the lowest point it was the least common denominator in terms of password complexity and length, and they were insistent upon synchronizing, despite the fact that Windows can easily support giant complex passwords. Mm-hmm. Everybody wanted their 1-point reset and synchronized it to then the lowest common denominator.
Mm. Talking about password expiration, I have customers who have 1-year password change intervals, and they're perfectly okay. We're measuring the password quality in their environment and trying to crack those hashes, and it's good. Why not? If the passwords are good enough, why password phrases, let's say, because it's not always RACF, why not allowing people to choose a strong one? Well, torture them when they choose it, so they will have to try a few times until they get the right one, but then they can use it for 1 year. They can even remember it. That's I see there are questions about MFA, biometrics. That's another interesting topic, because on one hand, MFA and biometrics these are technologies that are not as well understood as we want to believe. So probably one of the things that is not as well understood is that MFA will use a seed to generate a one-time password. This is the most common case. I'm not talking about certificates. I'm talking about the one-time passwords. And this seed has to be stored somewhere. And this seed cannot be hashed, because you need the original seed to generate the one-time password. So you have it on your Android phone, you have it on your iPhone, you have your clear text password that cannot be hashed. It cannot be hashed on the database side, it cannot be hashed on the service, it cannot be hashed in your device. So yes, it's random, it's very secure. But if it is exposed, it is instantly cracked because nobody needs to crack it. So that's one thing that one should keep in mind when using MFA. It's not bad to have MFA. It's not bad. Definitely, it's definitely good to have a second or third factor, but know exactly what you're doing, because you might even violate some privacy by storing this data everywhere. And biometrics, well, that's often a joke. I mean, the one thing you cannot change at all. So I wouldn't go into details with that. But I wanted to ask, in this respect, I know I shouldn't ask, but are you aware, guys, about any kind of adaptive or conditional authentication MFA solution for mainframes where one can have like a regular authentication with the password or the password phrase, and from time to time where certain conditions are detected to be required to provide a second factor?
So sort of a thing like I see sometimes when I log into Amazon from
the annoying thing. Yeah,
I flew to Germany yesterday and then had logged into Amazon and they're like, yeah, that doesn't look right. We've checked it, and that
exactly.
Sort of thing. Is that what you're asking? I've never seen anything like that. I don't know if any of you else has seen anything like that.
Because we've had in Germany an interesting case with PSD2. This is the European regulation for financial services that requires that multi-factor authentication is used at every time when users authenticate, not as before, just when they make transactions. And guess what? There was a real backfire, and consumer protection groups protested against that thing, and banks ended up not implementing it because it was too hard for the users, for the normal users. For normal users are normal people, the consumers. So they had to dial back and do something, and they ended up implementing a form of conditional authentication, which the users found a bit okay. So they found it acceptable. And this was an experiment in an 80 million user. Okay, there's 80 million people. They are not adults using banking, but there are still many users.
I get. So I'm going to ask you guys a question. So I get asked quite a bit. So two questions, and I'm curious on anybody who wants to weigh in on this. One, what sort of penetration do you see with KDF-AES? I mean, I'd say I see it at least half of the time now. Maybe 2 years ago it was 10%, and now it's probably more half or better. And then the second question is, I get asked this a fair amount, especially after the John the Ripper implementation and the impending Hashcat implementation. How do you defend being able to do this, right? How do you defend having things like password crackers that can just make basically a bad guy's life so much easier if you can offload the RACF database and basically dump out all these credentials? I get asked that a lot by people that don't work in the offensive side of security. How do you defend that, or what do you think about that? And both Nigel and Costin have done this in the past, so I would curious to get you on record as to saying why that, why do you defend having that sort of technology available?
Nigel, should
I? I think at the end of the day, and some of the things that we've all kind of been party to uncovering, you never truly know how secure a system is until you try and break into it. The salesman will always try and convince you that it's completely secure and that you don't need to worry about it. But what's the data that validates that? What kind of what backs up the sales literature? Now, okay, to an extent, part of that is down to standards. Are they following standards? Are they doing roll your own crypto, or are they implementing an approved crypto standard that's been peer reviewed? But at the end of the day, the only way to truly know is if you actually go and attempt it. Now, I mean, in terms of code breaking, if you were to look at, for example, the Enigma machines from during the Second World War, the Germans did an incredibly good job of designing that. And it was always said that had they been operated absolutely to the book, they would never have been cracked. The only way that they were ever cracked was because people took shortcuts. People didn't quite do things by the book. And it wasn't the design of the system that was in any way inadequate. It was the way it was operated that let it down. And I think basically all systems are like that. It doesn't matter how good your design of your basic system is. And I mean, as we've said, IBM have come up with some amazingly good design features and design implementations, but at the end of the day, you only know how secure it is when you actually go and try and break into it.
Yeah, I mean, from my point of view, if I share my point of view, it's called sales, because I'm selling a solution that does exactly that, doing password analytics and measuring the password strengths while maintaining the user's privacy and not revealing any clear text. So yeah, since I'm selling something like this, I do believe that that's the way to make sure that you are not vulnerable to such attacks, is to do the attack yourself and eliminate those passwords or password phrases that you find to be flawed, and make sure you do it regularly.
I've given people the answer of, I mean, most of us who have worked in a larger organization in the last 10 years have been intentionally phished, right? There's a tremendous number of companies out there that do now this intentional phishing, where you get an email, looks completely legitimate, and if you click on the link or open the attachment, you get a sign that says, oops, you've failed the test, and now you're, whatever, on a list. But the studies have shown that those types of that type of work trains users to not click on links, to not open attachments. And I think, to your point, Costin, if you take the sales part of it out of there, by analyzing passwords and giving that information back to the clients, we can help them change their behavior. I had a client who was still using DES, and I spent maybe $50 in Amazon time and cracked 5,000 passwords in a matter of hours, and all but one. And they were just kind of shocked by it. But I mean, I think my answer is, sometimes it takes that to change user behavior, right? It doesn't. The sort of IBM have delivered a fantastic product. Trust us, you should implement this. Doesn't always work. Sometimes people need to see sort of a demonstration of why something isn't secure or why something else is more secure before they'll willingly adopt it.
I mean, I've also found myself in the position many years ago where the organization I was working for, the auditors raised a concern over a particularly sensitive group of users, and that they had to have particularly good passwords. And the default password policy, they didn't want to nail down the default password policy to the same level as for this particular group of users. And they kind of said, well, we need to come up with a solution for this. And I thought, this is crazy. And I kind of flippantly said, well, I can always try cracking them, and if I can get them, I'll tell them that, they're not adhering to the standards. And a process was put in place that every week I had to try and crack this particular group of users' passwords, and they were a particularly sensitive group. And most weeks, I would get the odd password, and I would have to phone them up and say, look, your password's not complying to the complexity requirements. Can you change your password? And they would argue with me that black was white on the phone, that they were having a password that was meeting the standards. And invariably, it all came down to the fact that these people had learned to type on a typewriter. And they would press Cap Shift, and then they would type in the password. And they thought because Cap Shift was on, when they hit a number, they wasn't a number they were getting a special character. That's not the way it works on a computer keyboard. And usually I got to the stage where I had to say to them, look, you've got such and such character in the certain position. It's not a number. And I mean, but I was quite taken aback at the fact that the audit department of the company concerned thought this was a good idea, that they had somebody in the security department routinely cracking the passwords of a sensitive group of users. But it went on for years. But and from that point of view, I really don't think that people that weren't in the security side really understood it. You don't get a deep understanding of the security until you try and break it, and you actually learn either how easy it is or how difficult it is.
Yeah, agreed.
And by the same token, I mean, the best, I mean, I was always in the security side of things rather than sysprogs, but the best allies I had in the place were always the sysprogs. And most of the time, it was the sysprogs coming to me saying, go and nail down the security on this. We don't want somebody to break the system by getting this bit wrong or by getting in here when they shouldn't be in here. And that was actually what kept the system as secure as it was. It was down to the sysprogs telling us what to secure, because they didn't want to have to pick up the pieces.
Were those the same sysprogs who left behind little SVCs to do their business just in case they couldn't get access?
No, those were typically different ones, but yeah.
I kid, but we still find those from time to time.
Oh yes.
I would say just on that point, a while ago we were doing some testing somewhere and were able to brute force a user's set of passwords, even though they had gone to KDAS, because the backup had been left behind and unsecured, and it was the backup that we were using. It did convince them that it was a good plan to have gone, to have shifted their security, but they forgot to secure the one-off special backup they made right before they moved.
Excellent.
Which is just as well, because we weren't getting in any other way, so we were glad we found it.
As pen testers, there was no Windows in there. It's always a Windows system.
That's, yeah, that's not unlike the when we find like packet captures still on the system, TCP dumps and that sort of stuff still on the system where they were troubleshooting, you know, various network services and that sort of thing, chock full of usernames and passwords for your perusal.
Maybe another interesting thing, if you look at how passwords actually get hacked in real life, assuming that your attacker doesn't already have the KDFAS hashes. One way which is quite common is that your attacker will exploit vulnerabilities on the workstations, so the workstations of the users. And one way Microsoft is trying to get rid of this issue is by forcing Kerberos and eliminating the anti-LM authentication. So we should not have clear text passwords left in the memory space of LSA on the workstations. But this would also mean that in case of integrated authentication, we will see Kerberos used for the mainframe accounts. Just curious, how often do you guys see Kerberized logons for RACF?
Only in the lab.
Oh, I have one customer.
Honestly, I don't think I've run into any in the wild.
I think I've seen it for DB2 Connect a few years back. It seemed to be quite a popular way of using it.
I take that back. I saw it once for SSH. People were using it for SSH because it's easy enough to have Kerberos for SSH.
Yeah.
But I've never seen it in the wild.
In the other aspect, in terms of if you're trying to recover passwords, it's the fact that passwords have become so pervasive and they try and get in everywhere. And it's even in the mainframe, you can be accessing mainframe services through web browsers, which seems to be the preferred way a lot of the time. And you'll find that nearly all web browsers now will try and cache the passwords. And Firefox, Microsoft Edge, nearly all these browsers, you can go into them and say, show me all the passwords that are there, and it will list off all the account information, user ID and password that it's got cached. So that's one to watch. Every so often I kind of go in, even before doing this talk, whatever, I'd gone in and sort of thought, oh, best just check my browsers and see which ones are there. And you always get a surprise of which passwords have managed to find their way in, even though I'm in the habit of always saying no, never save password, etc. There's always some in there.
Yeah. By the way, on a different topic, because I know we spend many hours trying to understand how KDFAS actually works. Chad, how do you feel about vendors favoring obscurity versus using some standard algorithms that are proven to be secure and slow enough, and they implement their own, and then they keep them secret, and they tell us that, well, just believe we are doing best for you. In this particular case, we see that it's actually good. I mean, it's very good.
Yeah.
But
yeah, I mean, I've told time, you know? I've told my, and I you know, put the standard disclaimer here is I have a lot of friends in IBM in these areas, but I've told them the same thing, and I think that the platform as a whole could survive a little bit more openness and scrutiny, but particularly with crypto, I think everybody who works in crypto knows the number one rule is you don't write your own, but if you do, and you're someone who can and should, which certainly IBM falls into that category, then I think you have it publicly peer reviewed, and you release the implementation. I mean, that's been sort of the mantra of cryptographers forever, is that if you have to rely on the scarcity or secrecy of the implementation, that your crypto system is suspect. And we know because that they've used, you know, they haven't designed any primitives here. It's really just a matter of kind of how they put all the primitives together. But even so, mistakes have been made, a la your example about passphrases and DES, right? Or if you think about WPS on routers and that sort of thing, same type of attack, that even putting primitives together, mistakes are made, which is why you have these things published publicly and you have them peer reviewed. So I don't agree with it. Obviously, no one asked me, and no one probably cares what I think. But I think that I think it's important. I think it's important for for people to be able to stand up and say, here's why. And I think we as a group, as mainframers, along with IBM, have to move away from do this because I told you so, because trust me, it's okay, to here's why, and here's the proof behind it, and here's the testing, and go ahead. If you don't believe us, try it yourself. And to their benefit, or to their credit, I have seen that more and more over the years. But I think I could use a little bit more of it. Yeah.
And did you see the results of the poll, by the way, for KDFAS? So it was 64% of participants are using it. Well, let's just say that, well, not everyone completed the survey, but of those that did, 64% said they were using it and 36% said they are not. So
they have at least one system where they're using KDFA.
Yes. Yeah, indeed.
Are there any other questions? I know we're getting close to the wrap-up time here.
Any more questions? I mean, from a personal perspective, I mean, I have switched to, and I shouldn't really confess this about such a late, but I've been working with the mainframe for a few years now, and of course I've been brought up with the whole like 8-character password thing, and I have to say, a password manager has revolutionized my personal life, in that I can categorically say I have different passwords for all the different services that I use, and I don't know what those passwords are, and there's something like 30 characters, as a minimum. So all I would say, folks, if you're not using one, get one.
They're free.
And the thing is, though, and this is like, we're talking about making the life easier for the user, like in a commercial environment. if you're working in a bank or something like that. If you can provide that kind of capability, why does the user even need to know it?
They don't.
Yeah, exactly.
They shouldn't. Yeah.
Even an 8-character password, if you're really still stuck with those, surely there must be a business opportunity there to have some kind of password manager integration to
But
It's
Jamie,
there. They exist.
But
Yeah.
if you are going to use a password manager, so you are not going to know your password, why bother with the password in the first case and not use certificate authentication? It was discussed earlier for FTP, for example. Authentication with certificates has the great advantage of not ever transmitting the secret material at all. You can keep it in a hardware security module, like a smart card. On the mainframe side, it stays in a hardware security module. So private keys are wonderful for this perspective. You use the public key for authentication. End of the story. You don't need the password manager, even something like that. You can use the TPM in your laptop to authenticate. Because if you switch to a password manager, it means that you're no longer remembering your password. So why bother using a password at all?
Someone in the chat, Alessandro, asked about using Post-it notes to store your username and password, and everybody kind of gets a chuckle about this. But honestly, like if you're, I'm sure a lot of you are the IT person in your family or your extended family, where dad, granddad, mom, sister, everybody asks you for IT advice if you're that person. And I've told more than one person, like having a notebook with passwords in it as an individual is not a terrible idea. I mean, it depends on your threat model, right? But odds are someone's not breaking into your flat to steal your notebook with passwords in it. And it may be safer than otherwise. Now, that doesn't mean you should put it underneath your keyboard in your corporate environment and that sort of thing, right? This is a narrow band of people, but a password manager, an offline password manager, which is basically what a notebook is, for something, is not an absolutely terrible idea for depending on the person and what you're using it for and where you are and where it is and all that kind of stuff. But because the point is, it allows you to use multiple different passwords, and you're far more likely to get hit with password reuse as an attack than you are to have somebody break into your house and steal your password notebook, right? Password reuse is the number one way that people in businesses and everyone get popped, is because we crack some site with tens of millions of passwords, and people like the three of us throw those all into a large file and then reuse them again the next time we see your account somewhere, and it becomes that much easier to crack your password, right? So yeah, good suggestion.
Yeah.
In my case, they asked me to keep the password, so I'm a family business, isn't so I don't want to do that.
We'll be checking under your keyboard later on for Post-it
Yes,
notes.
right.
I don't want to do that.
Could I just ask a question? This is just out of curiosity rather than anything else. But do most people, particularly in the wild, if they're trying to password crack, use English dictionary words? Or because we found it before when that people who'd translated their password into the Irish language were rarely ever cracked.
Oh yeah, absolutely. And Costin mentioned something about sort of what we call like regionalization of your password lists. So if I go into the deep south in the US, in certain places where college football is very big, like I'll move that word list to be more sort of centric around that. And if I'm doing something in Dutch or in Irish or whatever, I mean, you absolutely have to figure out the character set and the word lists. Otherwise, yeah, most of people would use English and probably fail miserably at that.
But you will still keep the English language.
Yes.
That's always, it's the only constant. In Germany, lots of people use German language passwords, but at least half of them will have English passwords. So the constant in a password deck is that you stick to the English, and then, as Chad say, adapt it to the original culture.
Yeah, we got a very handy Norwegian word list from somebody at one stage when we were testing.
All right. Sorry, Nigel, were you going to say something?
Yeah, there's lots of different ones. The one that always amazed me was in the very early days, going back a few decades. Obviously, it was a financial institution I was working in, And what we discovered there was, before the passwords sort of mask requirements were put on, most users were choosing an all numeric password, which really surprised us. And that shrunk the whole key space right down, that it was so easy to get them. And what people were doing were, being a financial institution, they were used to working with numbers all the time. And what most people ended up doing was they just wrote, say today was Thursday, they would write, oh, change password. And that was it. They just wrote change password. They knew that password was that day's date. And it was all numeric.
Yeah.
And as soon as we put alphanumeric in, it kind of made it somewhat harder. But it made you realize that you need to understand what your user mentality is. And if you're dealing with users that they spend all day working with numbers, they think in numbers.
It's a psychological game, isn't it?
Yeah.
Yeah. Jamie,
Indeed.
thanks for having us.
No, thank you. I have to say, I think this has worked really, really well as a, I know we need more sessions like this where, have sort of an interaction. It's been really, we should have our own chat show, shouldn't we? The password chat show.
I think both people who watch that regularly would enjoy it.
Yeah. Do you think if we asked Ellen, she'd let us take over her
sure.
show?
Yeah, absolutely.
All right, thank you, gentlemen. It's lovely to have you on, and nice to see you again, Nigel.
Cheers.
Hope we'll see more of you in the future.
Thanks.
So,
everyone.
thank you. So we now have a 15-minute break. Well, just under. So if we can be back here at 4:45 GMT for the next session, where we have Brian Marshall from Vanguard, who's going to talk to us about Zero Trust. So do join us for that if you can. And thank you. See you in 15.